about TypeScript because it's the next big language we want to give people to author smart contracts on Algorand. It also gives us an entry into sort of the web dev arena. And I put this talk on the schedule today because we're at a very important point in the origin story of TypeScript. And there's a little bit of backstory, which Joe can talk about, that got us to this point. But integrating it into the Puya compiler that we use for Python smart contract authoring will be a transition. And the language will need to change a little bit, and we're sort of in a design phase right now. So we'd love to talk a little bit about where we've come from, where we are now, and where we're going, and get some feedback from this group, and also engagement in the beginning stages of this language's development, so that it is something people really want to use and are excited about. And already, what Joe has created has gotten great feedback. So Joe, a senior engineer from our engineering team, really kicked this off maybe a year or so ago.
It's almost 2 years.
Yeah,
I mean, TypeScript, you started it
last
overnight
Decipher.
at last Decipher.
Yeah.
I remember talking to you about it.
And Alessandro is our head of product at the foundation, and we also have our partner Rob Moore from MakerX, he and his team do incredible work to design like really high quality technology to enable people to build on Algorand through AlgoKit and that tool set. So I think without further ado, Joe should tell us, where do we come from to get to this point?
Yeah, so as Brian mentioned, I've been building TypeScript, which is a TypeScript language for Algorand. And I started building it at Decipher, was it November 22?
November 22.
22, right, yeah. So it's been quite a while since that work has started. And it started as just like a side project, but as it started to get more mature, we started embracing it more at the foundation, starting to do things like boot camps and making educational resources on it. And so really the whole reason that we work with MakerX to build Python, and I've been working on TypeScript or TypeScript, is because we want to make these languages more accessible. And as we saw with TypeScript, even though it was like super buggy, there still is a lot of bugs. Like, it's just myself been maintaining it for a while, but people are still interested in using it because it's just such a better developer experience than what was previously available with PyTeal and Beaker. And now we're in a place where we have the Puya compiler stack, which is much less buggy and has much more like production ready, and we can leverage that in many different contexts, including TypeScript. So essentially, the work that I've done with TypeScript is kind of just the start to. The way I view it is that we've been getting a ton of user feedback from getting TypeScript in the hands of people. And now the next step is, how do we take that feedback and make it production ready and integrate it with the rest of AlgoKit? And that's kind of why we're here today, is we're taking this work that I've started with TypeScript and then turning it into something that's production ready, that we can integrate with Puya and just make the whole Algorand developer experience better.
Yeah. So if I may ask at this moment, who in the room has used TypeScript in its current state? Oh, wow. All right.
Nice.
Yeah. So
Devs.
you want to talk about like how this fits into the AlgoKit roadmap?
Yeah, so we are at the point in the, let's call it TypeScript venture, that is, we're starting to decide on language design. And so there may be some trade-offs in between how good and easy it is to write in TypeScript and the overall end-to-end experience. So if you were here for the Python talk yesterday, maybe unit testing cannot be as powerful as it is in Python if we make certain decisions rather than others. We are at this stage of the idea. So if you have any feedback, we have a bunch of ADRs online, a lot of feedback forms that you can see how it could look like if we end up going down one road compared to the other. So this all ties in the AlgoKit ecosystem. By having the same compiler stack and multiple frontends, we can then focus on the optimizations at the middle and at the center of the compiler stack. And by optimizing that thing that is the common denominator of both languages, both frontends will benefit. So the languages will stay the same, but the outputted TL and bytecode will become more efficient. Yeah. So this is the vision, and this is why we're trying to bring TypeScript as much as possible or as much as you're comfortable with into the Puya compiler stack, because TypeScript is great. TypeScript is extremely easy to use, especially if you come from PyTeal. So it's, and at the end of it, we are building these things for you. So whatever you want and need, let's make it happen.
Yeah, and maybe just to give some context on like the design philosophy that I had with TypeScript, and what the design philosophy going forward is. So like for TypeScript, for me, basically how I started TypeScript was I wrote a TypeScript file that was just like hello world, and I was like, okay, how do I turn this into Teal and get this running on the AVM? So really the design philosophy was I want it to be as close to TypeScript as possible, and basically more or less make it feel like developers are running TypeScript in the AVM. And so when I first started, like TypeScript, you would use like the number type, and it would be literally copy and paste TypeScript that now works in the AVM. Over time, as it's matured, there's been points where we kind of have to realize like using all of these things that TypeScript has sets certain expectations in developers. For example, if we just use the number type, they might expect numbers to behave like a JavaScript number, where the AVM, it doesn't have negatives, it doesn't have decimals, it can go up to max even 64. So there's all these differences between TypeScript and the AVM that we've kind of had to reconcile with over time, much like Python as well. And so really the reason that we're here and thinking about the changes we want to make to TypeScript is we really want to solidify that stance of separating, or not separating, but more so making it clear what the AVM is capable of while still providing the TypeScript developer experience.
Yeah.
And so in a lot of the design decisions that I'll hopefully talk to a lot of you today and get feedback, but the design decisions that we're talking about today and going forward, that is really the central piece that we're trying to figure out, right? Is how we find that balance of being, super easy for a TypeScript developer to pick up, but also super clear about what they're actually writing is doing and how it's represented in the AVM. And that's kind of one of the big challenges that we're really focusing on.
So if I may, who in the room is familiar with the ADRs that were written as part of designing Algorand Python? Did anyone follow along with that process? Okay. So Rob, why don't you tell us a little bit about the design work that your team put into Algorand Python and how that's essentially going to happen again, is already happening for TypeScript. So people understand what that process is, how thoughtful that you've been about that, and how they can engage in that process.
Yeah, sure. So when we say ADR, it's an acronym that stands for Architecture Decision Record. Fairly, standard software development process. I'm sure many of you potentially using. And yeah, the reason why we do that is because when we dive in to build something new, we want to be thoughtful about the design of it and sticking to certain principles that we identify up front that sort of guide the guardrails within which we're trying to operate to build the thing. So I think if, off the top of my head, the sort of principles that we're thinking about for Algorand TypeScript are things like what Joe just mentioned, that it's an idiomatic TypeScript experience, so that any TypeScript developer that's used to writing TypeScript can come in and feel comfortable, and they can read the code and sort of understand what's happening. Another one then, which is kind of related, is the principle of least surprise. So the idea behind that, and that was a key one for Algorand Python. So the idea behind that is that you kind of go in as a TypeScript developer, in this case, you read the code, and the way that it executes on the AVM matches what you would expect in reading that code. That's really, really important because naturally smart contracts are often immutable once they're deployed, and sometimes are protecting large sums of money or value. So you kind of want them to be correct, which is kind of the next principle, which is the principle of correctness. So the idea is that we kind of prefer having things that are explicit over implicit. We want it so that when you write the code, it's clear that it's going to be correct. And by the way, these principles, they don't all necessarily nicely line up. So sometimes you might say, well, it's very explicit to write this like extra annotation, but it feels less idiomatic. And so there's an interesting decision that needs to be made of like, well, do you do that or do you do that? Which one do you kind of prioritize, right? And then I guess the other two principles are, firstly, that we want to minimize breaking changes from TypeScript because it's obviously something out there and it's awesome. We've got a bunch of people in the room that have been writing it. So, there's some feedback that's been put into TypeScript and an evolution in TypeScript. So that gives us a starting point for the language design. So we start sort of from that. And we either minimize breaking changes or where there are breaking changes, we do it in a way that we feel is easy to migrate. And then the last one is naturally that we're building on top of the Puya compiler architecture. Undoubtedly, there will be changes we need or want, whatever, to make to that compiler architecture. But ultimately, what we produce naturally needs to work with that. So, we basically, the way that's going to work is we take TypeScript, we turn it into a TypeScript AST, abstract syntax tree, and then we convert from the TypeScript abstract syntax tree to the
AWST?
We called it AWST. There's a bit of a backstory to that. So the code name for Algorand Python was originally Wyvern. I don't know why we called it that.
It's a dragon.
Cool.
Close enough to a snake.
We chose it. So we chose it because it's cool.
Yeah, pretty much.
And so it was the Wyvern AST. But the time zone that a lot of the people that are working on this is actually in Perth in Western Australia, where I'm based. And the time zone there is AWST, Australian Western Standard Time. So they just called it AWST and hence it's stuck. So the AWST is the sort of entry point to the Puya compiler. And it's essentially an abstract syntax tree. That's really hard to say. It's an AST. I just hate acronyms. It's an AST that is representing a high-level language. So the idea behind it is that you can create different front ends. So obviously we've got Python, we're working on TypeScript. Maybe there'll be others in the future, we hope so, and we hope the community creates them too. And it should be relatively easy to go from most modern, at the very least C-like high-level languages and sort of convert that into this AWST. And then once you've done that, the Puya compiler architecture takes care of the rest. It puts it through multiple optimization passes and there's a whole bunch of fancy stuff in there to try to emit really efficient teal code, right? And over time, we can invest in that, to Alessandro's point, to try to make it better and better. So yeah, they're the kind of sort of 4 or 5 principles that we're trying to follow. And like I said, there's tension sometimes between those principles. And I guess what we have to wrestle with as the team building it and hopefully get feedback from everyone is where do we go on some of those decisions?
Yeah. Before we get into a little bit more detail, do you have any questions from the room about this process or like what we're talking about here? Reactions? Okay.
And maybe before, if we go on, maybe just I can provide like a little bit of color of like why we're even using Puya rather than just, dedicating resources into what we already have with TypeScript. And the main benefit is that writing like the back end and the thing that does all the optimizations and the thing that powers all the features that are possible, by having like one stack that any front-end language can plug into, it makes it easier for us to maintain because we just have one code base that we can maintain, and it also makes it easier to like add features. So there's a lot of like edge cases that exist within AVM. So like if you have a box that's larger than 4K, like how do you iterate over it? And those things are relatively complex to integrate, and they've been something that's been taking a lot of time to integrate into TypeScript. And so if we can just have that effort once, and then we can bring that to TypeScript, Python, and any other language that integrates into the Puya compiler, we have like a much better ROI, and we also kind of align all the developer experiences on Algorand, where when you're choosing a language, you're not thinking of like, oh, Python supports this, but TypeScript supports this. It's, I like TypeScript better, I like Python better. And that's kind of the long-term vision, is that by having this standardized stack that all these languages can plug into, it's just a matter of language preference, and everything has the same amount of power. Everything, if there's a bug fix in one, it's a bug fix in everything. And that's kind of why that we're doing this transition period to integrate into Puya.
Yeah, at the end of it, we want to let you guys decide what is your preferred stack and pick that instead of being forced into a stack because of the feature set.
So it's drop spicy alpha or like future thinking. Or?
I mean, okay, we have an idea that we're gonna try and figure it out.
Yeah.
We're gonna try and figure it out, and it's given that every frontend has a common path, and that is the AWST. We will be trying to figure out how to. You can write a library for in Python smart contracts and hopefully inherit it and consume it from the TypeScript frontend. So this is the kind of weird thing that we'll try and achieve, and if we're able to do it, that's going to be fun.
Yeah. And then the awesome thing then is the entire ecosystem, regardless of which language that you're actually using, can stand on each other's shoulders rather than, oh, the Python thing has this cool library, but we can't use it over here and we have to like port it and waste time doing that. The hope, and we don't even know it's possible, we just kind of got some ideas, is that you could actually go, cool, the Python code library is there, it gets converted to AWST, and we have a way of importing AWST and you're generating a stub from it in the other language and then consuming that library code from the other language. That's the ultimate goal that we want to get to, which would be pretty nuts.
So I don't know, apologies, this is a new question then. Is this more of like an interpreted language, like in like IL, like coming out of .NET, for example, where I can write like VB or F# or C#, that kind of thing?
It's probably a good analogy. The question for the camera was, is this kind of like IL in the .NET ecosystem where you can write C#, VB, etc. on top of it? I think that's a reasonable analogy for AWST, except I'd just say that IL's really low level, whereas AWST is quite a high level representation. Like it looks kind of like C if you turn it into
read
text.
it quite
Yeah, you
easily.
could read AWST if you turn it into text representation, of course. But yeah,
Got
yeah. So yeah, that's some of the crazy stuff that we're thinking.
Yeah. So hopefully we're trying to bring in TypeScript exactly so that we remove completely the fragmentation. And it's, you have seen in history of programming languages like Ruby and Python are kind of born at the same time. Their communities, Ruby went down the web rabbit hole, Python went down the scientific rabbit hole, and this is how it split. We don't want that kind of fragmentation, so hopefully we're able to achieve it, and that's why we're going through the effort of bringing TypeScript in.
I think there's a question at the back.
I had one question. So, like in TypeScript, is there any consideration that is there like any constraint or anything that we need to keep in mind before developing? Like I do understand that it is like a new language that we have built and it's in initial stages only, so there'll be a lot of like improvements that will come. But if we are starting fresh, so is there any specific constraints or like and also like we do understand about the test, but in development specifically?
Yeah, so the question for the room, for the microphone was, when you're coming to TypeScript or TypeScript as a developer that's new to the language, what are the relevant constraints that you need to be aware of when you start developing with it?
Yeah, so I would say like if you're picking it up right now, really the main thing to be aware of with TypeScript is that it's version 0. So
0.90?
yeah, almost at 0.100.
That's going to be nice.
So really the main thing with when you pick up TypeScript is you kind of have to be ready to adjust to some breaking changes, not just through the process of going to Puya, but just in general as the language matures more, there's going to be things that we realize that need to change. And also, as I mentioned earlier, there definitely is like probably more bugs in TypeScript than there should be, but they do exist. So it is, we do have some projects that have gone in production with TypeScript, and at the end of the day, you have the teal code, which is the ultimate source of truth. So it's very important that you're cognizant of, what TypeScript is outputting. But if you're adopting it now, I'd say the main thing that you as a developer should be aware of is that there will be breaking changes coming. In terms of like the actual technical features that TypeScript is capable of, TypeScript supports basically every opcode in all the ABI types. So, and it also provides a lot of abstraction on top of like boxes and state. So basically anything you can do in the AVM, you can do in TypeScript, and it supports even like some more complex abstractions. Like for example, if you have a box that's larger than 4 kilobytes, which is the max size you can put on the stack, it does some abstraction for like iterating over that box in a way that doesn't exceed the stack limit. And a lot of these features of TypeScript come from someone, in a lot of cases, Patrick, because he's been using TypeScript for Ready and also for NF Domains v3. People come to us, myself, and say, "Hey, I need this feature," and that's kind of how we, that's how we iterate on our products, right? We listen to what people need. So, in terms of features, TypeScript has, like I said, full coverage, and it's capable of doing everything. You just need to be aware that it is not yet officially production ready. So, those are kind of some rough edges there.
I think the other thing I would add to that is, in a session yesterday, we discussed that building for the Algorand virtual machine is a different programming paradigm than writing code in other contexts. So you need to be mindful of the resource constraints on the chain and be thrifty with how you use resources and not just brute force things that you would be able to do in JavaScript or TypeScript off chain. So I think there's a little bit of a temptation to get a little fancy, I suppose, but you still need to understand what's happening on the chain, and you're not going to be able to achieve, for example, elaborate object-oriented programming on chain, right? So you still need to say, I've got a smart contract with a number of methods, constrained state, a constrained stack, constrained argument length and log length and so forth, and try to optimize within that as best you can.
Yeah, and I would say, at least my philosophy with TypeScript is that working within the AVM, there are boundaries that developers are going to hit, and there's just no way to protect the developer from eventually hitting like the opcode budget or something like that. And so the goal with like TypeScript, Algorand TypeScript, Algorand Python, is that we make it as easy as possible for developers to play and hit those boundaries and figure them out sooner rather than later. So like you can do like super complex arrays and iterate over them, but very quickly you'll hit into like opcode budget constraints. And so I think the general philosophy is that we want to provide something that it's easy for developers to play and find those like boundaries themselves, rather than having the language itself be the main constraint. Because like Brian said, there's always going to be things like resources that are not only unique to blockchain, but especially on Algorand, there's really interesting constraints that a lot of the times it's really hard to like conceptualize how those constraints actually impact your design until you start playing around with the language and starting that iterative design process. So yeah, that's kind of the benefit of these languages, that would just make it super easy to developers to like play, get their hands dirty, and like figure out what those constraints are.
Yeah. Question?
What are some big breaking changes that you expect to happen?
Yeah. So the question was, what are the breaking changes we expect to see?
It depends on on what breaking changes you guys allow us to do, pretty much.
There's one good example, that's an obvious one, is right now, if you're programming in TypeScript, there's like a global.d.ts file that basically just gives you ephemeral like types. But we're kind of saying, okay, idiomatically, like if you're writing TypeScript, you don't do that. You import types from a library. So that's one good example of a change that we would do, right? Is like, cool, we're going to actually import them. The nice benefit of that, of course, being that we can then get better IntelliSense for developers that are first learning it, because you can go, like maybe you implement like an OP from the thing, you go OP dot and you get all of the operations rather than them needing to know like what they are. Mm-hmm. So we think there's actually a benefit anyway from doing that, but obviously that's a breaking change, right? Like you would have to like actually add the imports at the top. But in saying that, potentially we could write a script that detects the methods that you're using and inject the imports for you. Like, I'm not saying we're definitely going to do that, but it's the sort of thing that we could potentially do, which would follow that principle of trying to minimize the migration effort, I guess, from TypeScript.
Yeah, and I think what also might be good is kind of taking a look at like the the design philosophies of Algorand Python and TypeScript, and like ultimately what we're trying to do is figure out like what works best from both of them and bring them together. And so like Rob mentioned like this idea of like explicitness, right? And TypeScript has a very like it does, for example, how it supports the ABI is kind of all under the hood, and as a developer you don't think about it. Whereas in Algorand Python, it's a little bit more explicit, and
we make it well aware that
Yeah.
you are dealing with the ABI.
Exactly. You're much more, as a developer, you're much more like cognizant of like the encoding and decoding that you're doing. And both of these things have like pros and cons. And so, a lot of the potential breaking changes that might be happening are things that add more explicitness to what already exists in TypeScript. So for example, one of the things we're thinking about is like, how do we support strings? Because the
Do you want to show the emoji example?
yeah, actually I can.
Also,
Well, while you pull
we
that
also
up,
have a question. How many of you
use strings.
use
in
strings in
contracts.
smart
Yeah,
contracts?
I'm really curious.
To be honest, because we don't.
Well, can we refine the question? How
We
many
might
people,
be barking up a tree nobody.
So aside from
By using strings.
yeah, so beyond just storing a string in a smart contract, do you interact with a string? Do you slice a string?
Oh.
Do you
Do you
concatenate
manipulate?
a string in a smart contract? Okay, some.
Yeah, just for logging.
Okay.
For logging.
Okay.
Okay, cool. Interesting.
Okay, makes sense.
Creating assets.
Asset names. Yeah, cool.
Like
Yep.
automatically based on some other
Yeah.
information or like a metadata string.
Okay,
those
cool.
kind of stuff. So
Yeah, that makes
basic
sense.
concatenation of things or slicing.
So there's like a little bit, I'm getting the sense, there's a little bit of string use, maybe a little bit of concatenation. Other than that, mostly it's like numeric stuff. Is that a fair kind of...
But not like
And bytes, yeah, cool, yeah, it makes sense, of course, yeah. As a side note, while Joe pulls that up, while we go through this process, there's also changes that might go the other way. So,
Yep.
as an example, one of the things that Joe did in TypeScript that we thought was really cool was that if you have a public method, that automatically gets exposed as an ABI method, so that you don't have to annotate every single method. And then the private or a protected would be like a subroutine. And we thought, oh, well, that's actually really
Yeah.
cool. That like because conceptually, and what we've put this in the Algorand Python documentation, we've realized that when you create a contract class, when you deploy it to chain, that's the equivalent in an object-oriented sense of instantiating that class as an object. Particularly because when you're doing global state, you actually store it in a variable. In an instance variable in the class, and so the concept holds really true. And so because of that, it makes sense in object-oriented languages. If you have a public method, other people can call it, and so that conceptually flows through really nicely. And so we're thinking of actually going back to Algorand Python and saying, okay, cool, if you have a method that starts with an underscore, which is the Python idiomatic way of saying this is a private method, then that would be a subroutine without you having to necessarily add subroutine. Like that's one of the things we're kind of looking at. So this process is useful because it allows us to look at both languages and trying to, like you say, idiomatic differences aside, try to sort of bring them in line and take some of the ideas from TypeScript as well as maybe inject some of the ideas from Algorand Python and hopefully end up with something that's
Something really
consistent
cool.
across the languages. With deliberate idiomatic differences, so that obviously it makes sense. It's the principle of least surprise. So, yeah.
Yeah, and yeah, just
This string example is brilliant.
yeah. So this is a really this is a good example of like things that like problems that emerge when you think deeply about like how these things actually behave in TypeScript versus AVM. So let me actually scroll up here. So this is a GetValue at index is a method that takes a string and then takes that index and will return, as you can see here, we just index into that string to return what the value is. And when you do that in TypeScript, right, so I'm going to give it the thumbs up emoji and I get the thing at 0 index, that's going to be the thumbs up emoji. But the big challenge is that in the AVM, we don't have opcodes, or it'd be very inefficient to implement opcodes to work with strings. So this thumbs up emoji is actually 3 bytes. So when we do that in the AVM, when we get the value at index 0, that's returning the 0th byte, the first byte. And so what's what would happen here, if we just natively support the string prototype as is, we would have divergent behavior. And this is what we really want to avoid, where the same exact code would behave differently than it does in TypeScript and in Algorand TypeScript on the AVM. And so these are the small details that, as we start making this transition into integrating with the Puya, that we're going to be much more thoughtful about and think about what are the best ways to solve them. All right, so I guess...
And there's, to add to that, there's probably two things here. Like, so one is it violates the principle of least surprise. Like you think, oh, that's going to work, but it does something completely different to what you expect. But the second one is the unit testing support that we showed yesterday, where you could, unit test the Python code in PyTest. We're going to be building the same thing for TypeScript, and it won't be delayed. It'll come with the versions of TypeScript as they emerge. So it's going to be built from the beginning. And so when we write this Algorand TypeScript code, it needs to be able to execute in like a sort of Node.js style environment with execution semantics that match the execution semantics in the AVM. So code like that then is very problematic because we're kind of like, oh, well, what do we do? Now there are some little tricks we can do because we can actually run the TypeScript code through a custom transformer, which is a part of the TypeScript language. And so we can do some little bit of voodoo magic, but we're trying to limit that because, again, we don't want to violate the principle of least surprise. So every time we're doing voodoo magic, it means we're probably bending the language a bit. So again, there's tension between
And there are
these
risks
things.
also.
Yeah,
associated
well, and it's
with
more
that.
complex. There's more code to maintain. Yeah, of course. Yeah, right.
No.
As a side note, the fact that TypeScript doesn't support operator overloading is the bane of our existence.
Yeah. Hurts.
And if anyone wants to have some light bedtime reading, go and read all the
There's a gigantic
massive threads and then the TC39 JavaScript, like the ECMAScript council, like it's a whole thing. It's really, really wild.
So for this example, like, can you say, I want this to be as like TypeScript as possible. I don't want to introduce like a new string syntax. I want it to be as easy as possible to write strings. So, but I'm going to make it slightly different from TypeScript and say, like, there is no Unicode. Is that an option in your kind of compiler stack to just say, like, we do not support Unicode in our Algorand TypeScript?
Yeah, I mean, look, that's one way to do it. I think it's still a bit problematic because you could construct a byte array and turn it into a string type, and the way that would execute in TypeScript versus not would actually still be different. But what we're more thinking is, do we make it so that you can use normal string syntax, but a lot of the prototype methods on string just will throw a compiler error if you try to use them. So if you do a slice or an index or whatever it is, we just go, no, you can't do that. Now the downside of that is that the IntelliSense is a little bit less useful, and so that might be confusing. But the upside, of course, is that the code that you write is like much more idiomatic TypeScript rather than having to do a type wrapper around it. So some interesting pros and cons.
But does it mean you wouldn't be able to do like indexing into a string?
Yeah, we would just go, no, you can't. The compiler would throw an error. So the IDE would show it up okay, but then the compiler would be like, no, you can't index a string because we don't support that.
Yeah, so we actually have like an example of this, and so these are kind of the two approaches that we've been thinking about when it comes to how we handle this string problem, right? Yeah. And so the one on the left, what we're calling like the extended string prototype, is where we have the native string support, but there's some things in the prototype that we don't support, like doing the brackets to like index into it, right? And so what would happen here is that the compiler would throw an error. And then the alternative is that we have, like Rob said, we have we just straight up don't support string at all, and we require a completely new class. So if we scroll down here, this is what like it would actually look like. So instead of using the brackets, we have a specific, didn't realize I would open up. We have a specific method that you do .getByte instead of the brackets, because the brackets, it has the semantics of the like UTF-16 character, whereas getByte is explicit and the developer knows that that's getting the actual byte at that index. So there are, like, these are kind of the two main things that we're thinking about. And throughout today, we hope to kind of have more formal conversations with you guys and see which ones you prefer. But that's kind of the general idea of how we're thinking about this. And there's a lot of cases that are very similar to this, where like we kind of have to choose, do we want to have, you know, more familiarity, but maybe like a less, like more polluted IntelliSense experience, or do we want to have, you know, control of the prototype and more explicitness with a little bit less familiarity?
Yeah,
So
with syntax that like is a little bit weird at first glance, right? But
Right.
yeah, it's pros and cons, right?
And this is, I think, just one of the probably 50 decision of this kind of caliber that we have to make.
yeah.
So it's
So I think at
you
this
guys
point,
are using it. That's why we're
Yeah,
also
we'd love to know
asking
what
you guys
everybody's-
what do you
Yeah.
think, and what do you want.
come talk to Joe, and also the Puya TS repository is going to have some ADRs. We'll send out some information. You know, if you want to sit down and read through this stuff and really think through it, and it does take some time if you want to commit to it, we'd love to have your input as this crystallizes into our next smart contract language. So thank you to our panelists today. Thank you to our panelists today.